All right, let's look at the homework 2.5, problem number 3. All right, so we want to find an equation of the tangent line to the graph of this function given at x equals 2. All right, so let's do that. All right, so let's see. So we always need two pieces of information, right? So first piece of information we need is the point. So we have point x1 comma y1, right? So x1 in this case is 2, so right here. All right, so I'm going to put 2 there. All right, then we just need to find the f of 2. So f of 2 would be, all right, plug in 2, so it's going to be a 2 square root of, all right, you have a 2 squared, that'll be 4. 4 plus 45 is 49. And the square root of 49 is 7, so 2 times 7 is 14. Right, so the point is 2 comma 14. Right, so we got that. And number 2, we need to find the slope. So I'm going to call the slope m, which can be found by taking a derivative of the function and plugging 2. Right, but we need to find the derivative first. Right, so first thing I would do is we rewrite this function a little bit. So since I don't like square root, I'm going to rewrite it as, all right, so we have x squared plus 45. All right, so it's a 1/2 power. Right, so it looks like we have two things multiplied together. So this is the first guy. Let's see, so this is our first guy, and this is our second guy. So we need to use the product rule, right? So take the derivative, so f prime of x is equal to, right, derivative of the first, which is 1, times the second guy, so I'm going to copy exactly the same thing, x squared plus 45, raise it to the 1/2 power. Plus, right, first guy is x times the derivative of the second guy. So I'm going to put 1/2 in front and keep the same inside function as it is. Right, then subtract 1 from the power, so it's going to be negative 1/2. And then multiply by derivative inside, which is going to be 2x. Right, so let's do a little bit of a cleaning up. So we have 2 on the bottom here, and we can cancel the 2 on top. Right, and another thing we can do is I don't like a negative power, so I'm gonna start writing a fraction here. All right, so I'm gonna put the 1/2 power back to square root. So first term is square root of x squared plus 45. Right, and the plus. Right, so we have there are two x's. So you have x here multiplied by x, so you have x squared on top. So x squared lives upstairs. All right, so we have a negative power on x squared plus 45. So x squared plus 45 lives downstairs. Right, then we have to take care of this 1/2 power. So that's square root. Right, so we have that. Right, then the next thing we want to do is we want to combine those together so we can take the common denominator. All right, so this one doesn't have a denominator, so you can think of it as this is just over 1, right? So to take the common denominator, I'm going to just take the denominator square root of x squared plus 45. Right? Then since we want to multiply the denominator by square root of x squared plus 45, we have to do exactly the same thing to the numerator. So square root of x squared plus 45 times itself is just to get rid of the square root, right? So x squared plus 45, right? Then the second term will already have the denominator, so we don't have to do anything. So plus x squared. All right. So you can see that this is going to be simply, we can combine x squared and x squared together. We can write it as a 2x squared, and the rest is 45 over square root of x squared plus 45. So we can find the slope by just plugging in 2 there. So it's going to be, we have, all right, plug in 2, so 2 times 2 squared, so it's going to be 2 times 4, 8. 8 plus 45 is 53, so we have 53 here. All right, so then you have, again, it's 4 plus 45, so square root of 49, so that's going to be 7. All right. All right, so that's the slope, and if you want to find the equation of the tangent line, it's going to be y minus y1, which is 14, is equal to 53 over 7, then quantity x minus x1, which is 2. All right, so let's type this guy in. All right, so what we have is actually this is we have to write it as y equals. I have to do a little bit of work here. All right, I'm going to say add 14 so that the y is by itself. So y is equal to, and we have a 53 over 7. All right, let's see, should I distribute? I'm going to actually keep it as it is. So how about this? X minus 2 and plus 14. All right. All right, let's see if the system takes this answer. All right, so we have 53 over 7 and x minus 2 and plus 14. All right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, so let's see. We have to use a graphing utility. All right, so then choose the correct picture. All right, so let's do that. And I'm gonna just open up GeoGebra here. All right, so I opened up a GeoGebra, and we're gonna type in actually I'm gonna just call it all right, y is equal to x times square root of x squared plus 45. Actually, that's not right, so I have to put 45 inside the square root. All right, so here. All right, so this is the graph we have, right? So it's almost as like a straight line. And if I don't like it, you know, we can always change the scaling, but that's that. And then we need the tangent line here. All right, tangent line would be, so this is going to be at, so let's put a point, 2 comma, let's see what that was, I forgot what the point was, 14, 2 comma 14, right? So let's do that. Let's see, open up here and GeoGebra here. All right, so I'm gonna put point 2 comma 14. All right, so we're looking at the, see, I can't see the, so I'm gonna just go back. All right, so this is where the point is. And then we want to find the tangent line at that point. All right, so that was, we found that to be y is equal to 53 over 7 times x minus 2 plus 14. Right, so we have that. All right, this is very, very difficult to see. So what I can do is I'm going to actually change the scaling a little bit here. So I'm going to grab the x-axis and see if I can change it. Oop, I cannot change this. I think yeah, oh, here. All right, so if I stretch the x-axis a little bit, and then you can see that this is what it looks like. All right, so let's see if we have that. All right, this is not it, and this is not it. This is actually crossing. It doesn't even look like a tangent line here. All right, this picture looks good, and this is not right because the point of tangency is in the wrong quadrant. So this is going to be the correct answer. All right, so let's check the answer. All right, submit for testing. All right, it came back, and looks like we got the correct graph as well. All right, that's it. I hope that this was clear.